I'm Nick with NP Environmental, and we chose the Bruce Thompson project for our case study today. Let me tell you a little bit about NP Environmental, a little bit about our company. This picture here, I'm actually standing with one of our local politicians here in Oneida County, persuading him to promote our technologies here locally. And actually a company we do quite a bit of business with. We're standing in front of the owner's house. He did the conversion to a ground source heat pump a few years ago. But we're a company. We started back in 2004. We specialize in ground source heat pumps, air source heat pumps, anything to do with HVAC technology for a building, manufacturing, whatever it may be. That's what we do. We design and build the systems. We can do residential, commercial, industrial. And the reason I list heat pumps from day one here is because way back when we did start the company in the beginning, when heat pumps didn't have the notoriety that they do today, which is still on a small scale, we believed in heat pump technology. And when you look at numbers like 400% efficiency, it seems impossible, because when you think of fossil fuel based systems, any type of combustion process, there's going to be waste. So with that waste, your efficiency is going to be below 100%, because a portion of that is going right up the chimney. With a ground source heat pump, when you contribute the earth factor with electric technology and a heat pump, you combine the two, and that's how you achieve that higher efficiency. When it comes to HeatSmart programs, we actually, years ago when this program started, we were delighted to hear about it. And we came to know about the program through a project we did in Ithaca before the inception of HeatSmart. And one of the customers that we did work for, David Quinn Jacobs down there, it was a project that, I think there's some information on some earlier webinars, but he had referred us to a guy by the name of Mark Whitmer, a local to Ithaca, and they had, introduced us to the program. And we were excited about it because we knew that heat pumps required a level of education, a level of familiarity that we're just starting to see today. So with the inception of the HeatSmart programs, and individuals like Jonathan, individuals like Lisa, you have Bennett on here, Lindsay Spear from CNY HeatSmart. These programs really help to bring that home and to bring that information out there. And as you'll see today in this case study, we're excited about these opportunities because it gives us a chance to talk about the real world life of these systems, so you can tangibly see get your hands on something that that seems like 400% can't be achieved, and we will show you how it can. Sets us apart, people. You look at the individuals within our company. You look at people. You look at the influence that Jonathan has in Tompkins County, Bennett has in Otsego County. People make the difference, and it's funny. I have conversations with individuals all the time about, geez, why isn't heat pump technology catching on quicker? Why aren't heat pumps being used everywhere? And it's just a matter of people, individuals taking that leadership role to say, hey, here's a better way. And when I look at it, the viewpoint that I see it from, it's challenging for me to see it otherwise, because you look at a product that works so well, it lasts so long, it has so many benefits. It'll be here as long as the sun's shining and this earth is here. This technology will be here. And as a company, we are firm believers in utilizing the resources available to you. And every region across the world has different resources that they can use, but utilize those resources sustainably. That's important to us. And the passion, the reason I put passion at the bottom is one of the requirements when we bring individuals into our company. And the thing that I look at the most is the passion for the industry. Because if you love your job and you have a passion for what you do, it really comes naturally. And that's one of the things that we look at here at NP. And when we get to offer a product like heat pump technology. It's so great. I mean, it's hard to express how good it is to be in this industry, because you have a product that benefits the consumer, it benefits society as a whole, it benefits the team here at NP. The benefits are just across the board. It's really, really pretty simple. So heat pumps are for everyone. And I'm a firm believer in this. Every time I have an application come about that, that could be applicable to heat pumps, I say, yeah, that's right. And I put this number up here, 35 to 135 degrees. And, Lisa asked me the question, Nick, what is that? Well, 35 degrees for the cooling side for heat pumps, we can produce temperatures way down to 35 degrees. And you can use that for industrial applications for cooling the press that you see in the lower right-hand corner here. And then you have temperatures that go way up to 135 degrees. If you look at your current boiler system today, you're operating at 160 to 180. You don't really need to operate at that high of a temperature to achieve 70 degrees of heating comfort, the temperature within your home. You just don't need numbers that high. And if distributions are designed properly, installed properly, and there's a thought process that comes about for these systems, you'll be comfortable and you can operate at a much lower temperature, reducing your waste, and you don't need that. But this range is what heat pumps can be applicable to, from small homes, modular homes, small homes, even homes down to micro homes. You can look at older homes, like you see the home in the middle here. We have a lot of homes, older vintage, great application for ground source heat pumps. On the commercial side, a project that we did in Hamilton, New York, their municipal garage, they were burning thousands of gallons of oil. It was, I couldn't believe it. And they had a resource right to the right-hand side of that building with a well that produces just tons of water, hundreds of gallons a minute of water. So we said, geez, why not utilize that resource and hook it to a ground source heat pump? And we expected to heat half the building, and we're heating the whole building, because what they have in front is a shop for working on their equipment, and back is storage. But these pieces of equipment are coming in with snow, so they have to melt the snow and work on this equipment. We have the resource available to us. We used it. And then you look at new construction applications. New construction applications are a good opportunity to where the heat pump specialist, the engineer, can come in and design the distribution system right around the ground source heat pump or the air source heat pump system. So when I say heat pumps are for everyone, I really truly mean that heat pumps are for everyone. And if you fit in that temperature range, you're in the sweet spot. So the case study why I chose the Thompson family home, their family has lived in Ithaca for 43 years. Bruce, a physics professor, Ithaca College, his wife, Katie, a psychotherapist, and Bruce was, heavily involved in the technology, and his wife was, there was a lot of nuances with this project, because as you can see, the home, beautiful home, this is a larger home, and the two of them were part of the construction of this complete home. And when you walk in, you look at the woodworking, you look at the different finishes within the home, they had specific criterion that they wanted to meet with their system. And this project, which was cool because Bruce, being a physics professor, he could understand the technology behind the refrigeration cycle and what refrigerants can do and how heat pumps operate. So he was heavily involved in the whole process, and it was a cool project working back and forth with him, because he was so interested and he really just had a passion for what was going on, and he could clearly see what the advantages were from a ground source heat pump. So the main reason he made the change is they had a wood-fired boiler, but they had a propane boiler as a backup supplemental, and the wood boiler was at the end of its life cycle, the propane boiler at the end of his life cycle, and they wanted something that was super efficient, eco-friendly, but they also wanted cooling too. And at the time that Bruce had his radiant installed in his home, they had used an older technology tubing that could have the potential for failure. So we had recommended a system to Bruce that would provide cooling, but also could do heating if ever there were the case that the older technology radiant did have a failure. But ultimately, he needed a replacement. So if he were to invest in a new wood boiler or a new propane boiler and then put cooling in, he was looking at all of those additional costs. Well, you can do it with just one system. That's why he chose the ground source heat pump. So ground source heat pump can be connected to some different types of loop fields. As you can see to the right-hand side here, this is a vertical loop. You don't really see much because you have two bores here, and piping connects in and comes into the home. For Bruce's home, he had quite a few acres on his property, but a lot of it was finished landscape and rock was super close to surface. So for us, this goes back to that utilizing the resources that are available to you. He had a pretty large system. It was a 10-ton system, big home, a lot of stuff going on. So we chose the vertical loop route. We recommended that to him because we did have rock close to surface. Rock performs great. It's easy to drill in rock. So for this application, it worked out well. And then an alternative configuration, if, as you can see, if you look at the picture with the horizontal loop, it's a slinky loop you're looking at underground, and you can see that earth is easily excavated. So for that project, it was a horizontal loop that was the best fit. But these are two configurations. Also the open loop that we talked about for the Town of Hamilton project. And then you can also do a pond loop where you're submerging a loop into a pond. But we wanted to show a couple of examples in thinking about the resources that you have available to you, because every piece of property is different. The geology is different from location to location, and the vertical loop is what made the most sense for the Thompson project. The equipment. Why show a picture of Bruce standing here with his hand on this unit here? It's called a ductless fan coil unit. And we get a lot of questions around these fan coil units and how you would do cooling with a hydronic system. And this unit on the wall here, as you can see, it's a pretty attractive unit. It's not significantly invasive, but also it met the needs for Bruce and his wife, because they had a certain level of aesthetics that they wanted to reach within their home, and they weren't looking for too much intrusion, but they also wanted the advantages of cooling. We actually, in the beginning, looked at putting duct distribution throughout his home, but the way that his home was designed and the basement portion was finished, it really didn't make sense to put ductwork in his home. It would have been just too much of a challenge. So we opted to go with the Myson fan coil unit here that you see. It's a wall-mounted unit, can provide heating and cooling, but also the advantage for Bruce, if there were any failures in his radiant from that old tubing installation, he would still have heating as a backup. And these units are great because you can provide you with, still have the radiant heat. You can have the air for heating, which heats up much quicker. And then you can also have the advantage of cooling in the summertime. These are zoned per each individual room. You have these located throughout his house. So with the system, it's a Bruce gets. He gets a quiet system, it's a versatile system, very efficient system. And at the bottom, as you can see, his existing distribution did require some upgrades in order for us to retrofit to his house. So a lot of homes that we walk into, there are distribution upgrades that have to be made to fit with the ground source heat pump system. However, in some cases where you saw the smaller home in the beginning there, they had adequate distribution in place. Everything was there. So they could directly go over to a ground source heat pump, no distribution upgrades. They get heating and cooling and everything is done. So when you look at the different applications for ground source heat pump, the versatility of the system is just tremendous. And for Bruce, he needed the ultimate in versatility because of the nature of his distribution system and what his demands were. So the results. So this is a larger home with a total cost, you're looking at $105,000. When you look at that number, you say, geez, that's a huge number. You're looking at a lot of cost here. But this goes back to the fact that ground source heat pumps, air source heat pumps alone are a fit for every application. And it depends on that application and what your expectations are for the system and what you want to do that will bring that to life for you. And if you look at the other end of the spectrum, you can have systems all the way down to $15,000, $25,000. But if you look at the incentives for a project like this, you're looking at a total incentive of $42,000, and that includes the federal tax credit. So at this time was 30%, and then it includes the rebate, which is right around $14,000. And then if you look at his operational cost savings, and this is comparing to propane, at the time we did this analysis was $2.35 a gallon. He was actually spending in the neighborhood of $3 to $3.50. Your annual operational cost savings is $5,000. And this is on a system that's going to last. The ground loop is there forever. The interior components are going to give you 25 to 30 years of life. And when you think of an investment like that, I look at that number and I see that and I say, that's about the price of a car. And when you look at a car, you pull that thing off the lot, you put the money down, and immediately it declines in value. But if you look at an investment into your home, which your home, your building, anything that's going to be there for a period of longer than 15 to 20 years, which you'd be hard pressed to get 15 to 20 years out of a car, that's going to be your most significant investment in your life. So when you look at heat pump technology and you think long term, it's a different way of thinking, but it's a resource that's always going to be there. As long as the sun's shining, the earth is still here, and the earth is that big solar collector, it's going to be there forever. So when you invest in technology, heat pump technology, you're investing in a forever technology. And we've done replacements of heat pumps for individuals that have been 30, 40 years. We use the same ground loop. We put a heat pump in. And we did calculations for an average home, 2,000 square foot home. They're saving $60,000 over that life cycle. $60,000, that's a tremendous amount of money. Imagine what you could be doing with that amount of money. So for this specific application, when you factor in the replacement of a conventional system at $20,000, that's because he would have to upgrade his boiler and put cooling in place. You get an 8.5-year payback period. But when you think of payback period, any conventional system has no payback period. It just doesn't exist. With this type of technology, there is a payback period. There is that benefit, and there's that long-term benefit. So you get worry-free reliability, great comfort, and you're getting emissions reduction, carbon reduction. The advantages are just through and through across the board. So today's offer, now the incentives have changed. It's gone over to the utilities. Your total incentives are $38,000. Your federal tax credit's a little bit less. The program offered through the utilities, depending upon which application, equals out to be close to the same. You still have those operational cost savings. And then I list the home value increase here of $40,000. That's a question I get a lot. Well, geez, Nick, how do you calculate a $40,000 increase in the home value? When you look at the savings, you look at the total value of a system and you look at it over the life cycle, there's a study out there, and I'd love to share it with anybody. Unfortunately, I don't have time today, that backs up that number and how you would calculate that. So in today's incentive market, you're looking at a 9-year payback period. But the other thing that we have today that we didn't have a couple years ago at the time of Bruce Thompson's system is new low interest financing options. The access to money is low right now. And NYSERDA is offering some good low interest financing options that are great to invest in this technology that's going to be saving you money year on year. And that's the end of the presentation. Thank you.
Nick, what a great presentation. It's pretty cool to see how a hydronic system, some people think you can't put in heat pumps if you have a hydronic system, but that's not true at all, as you could see. And you can still figure out how to get air conditioning as well. So I think it's pretty exciting for those homeowners at that beautiful house. Now they have radiant heat under the floor, but they also have air conditioning, which is super great. So NP Environmental is one of our 4 competitively selected partners, installers. On the heat pump side, we have NP and Daily Geothermal. And on the home installation and air sealing plus heat pumps, we have Halco and Snug Planet. You can find the case studies done by the other 3 installers on our website now if you missed those and like to take a look, please do so. And I want to also say that Nick is an installer partner for, or NP Environmental are an installer partner for Central New York's HeatSmart program, as well as HeatSmart.Sego. And I know some of you are joining this webinar from those territories as well. Okay, so we invite you and encourage you to get started with the HeatSmart program. And the way you do that is you enroll on our website, HeatSmartTompkins.org, or with the CNY website or HeatSmart.Sego's website if you're in those territories. There's also other HeatSmart programs around the state. And if your county is not covered by one of the HeatSmart programs, just give us a call and we can try to help you out as well. What enrolling does is it doesn't obligate you to anything. You fill out a short survey and you select one or more of our installer partners to contact you to assess your home for what they would propose to do and give you a price quote for that work. You can do one or all of our installers, so especially for a big heat pump installation, we definitely recommend getting more than one quote. Home assessments are free and there's no obligation to you. So whether you're ready to change out your heating system right now, or you just want some insulation or maybe a water heater, maybe you are thinking about what to do a few years from now, either way, the time to enroll is right now, and that starts a relationship between you and HeatSmart. And that means that Jonathan and I are here to help you navigate the process, or the HeatSmart directors for your area. So now we're going to turn it over to questions and answers. I'm going to unshare my screen, and you may type your questions for Nick or for any of the HeatSmart directors in the chat, or you can unmute yourself and ask it with your own voice. So let
Hi,
me
Lisa.
just,
I'd like to ask a question.
oh, okay. I'll
Nick,
call on my co-director, Jonathan Comstock.
Nick, I think it was just last week, but anyway, in one of the previous lunchtime seminars, the comment was made that hardly ever did the hydronic systems get installed without a major upgrade. And you were talking in your talk that sometimes you do, sometimes you don't have to do a major upgrade. And I wonder if you could just talk a little bit more about that in terms, and I know that probably some of that depends on the nature of the homes and their age and what kind of heating systems are most prevalent, and that can vary from area to area. But in the Tompkins County area, do you have a sense for whether it's more common for people not to need major upgrades, maybe minor ones? I know there's always an upgrade to install a fan coil, for instance, because you have to add plumbing. But anyway, I wonder if you could just address that a little bit more. How common is it that you have to do a major upgrade?
Jonathan, that's a really good question, and I love that question, because if you look at the residential sector of the market and you look at mechanical systems that are installed, unfortunately, the distribution is always an afterthought. It's not anything that's really pre-planned or much thought is given to, because the old way was to install the biggest burning unit that you could throw in there, burn as much fossil fuel as you can, and do an undersized distribution system that had a tough time keeping individuals comfortable within a home. So many times that we walk in, you're going to see distribution upgrades, whether it be on the forced air side, the hydronic side, whatever it may be, because, I think the one thing I like, and others may argue this, is that there's standards set in place now for putting in a distribution system, and there's measurements taken, and there's a process where the quality control is there, the M&V is there, in order to determine if a distribution system is adequate for a home. Because you can have the best heat source in the world, no matter what technology it is, and have a underdesigned or poorly installed distribution system, and it just won't work right. So we've walked into homes numerous times where we can look at even a conventional distribution network of components and find a problem almost immediately and fix it. So unfortunately, it is the case that a lot of time we do see that distribution upgrades are required, regardless of the system you're operating, and the system that's been there has just been limping along, poorly performing, and leaving the customer uncomfortable in the home.
Nick, did they have radiant upstairs as well as downstairs?
They did. They had radiant throughout the house, and they didn't need to do any upgrades to the radiant system. The main benefit that they were able to get from the fan coil unit was the cooling, and the side benefit to that was that it could also do heating.
So our next question is about the fan coil. Somebody would like a little more detail about how those fan coil systems work with in one of these homes.
Sure. So
fan coils.
There's a few different flavors. The one you saw there was basically, we call that our floor mounted unit, our low wall mounted unit, water to air fan coil. Then we have a high wall mounted unit similar to what you would see in a Mitsubishi mini split system. And then you also have a ducted unit where you can connect to ductwork. And the major difference between that and a standard forced air system is the heat source is a hydronic heat pump that produces hot water for heating and cool water for cooling. And on the cooling side, we just have to be sure that we take care of the condensation, because you're dehumidifying during the cooling process with those fan coil units.
That's great. So John asks about the previous system this homeowner had. They said, was it strictly propane or wood with a propane backup? How come they were spending so much on their heat?
It was a propane system, and that was in comparison to propane. So if you're looking at, I think we did the calculations at the $2.35 a gallon, but they would also see fluctuations all to $4 a gallon. So their average savings annually was $5,000.
Yeah, that's one of the great things about converting to heat pumps, because with the fossil fuel systems, you see great price variability, and it's hard to budget into the future when you don't know how much your heating's going to cost. So with the cost of electricity, there's much less fluctuation, and you can really know from year to year how much it's going to cost. Much better. So Brian says, a neighbor recently had a vertical installation in a small residential lot. I have a much larger lot that would permit a horizontal installation of the coils. Question is, how do costs compare between a vertical loop field and a horizontal ground one? And how much area do you need for the horizontal installation?
So depending upon geology will determine the reduction in cost. However, the horizontal loop will always be the more economical option when you're talking ground loops. The vertical option can vary quite a bit, and it really depends on depth of rock. In the example that I showed you there, we had rock at 4 feet. So the depths to rock was close, so we didn't have any additional casing costs, and it's easy for the driller to drill into rock. However, the challenge with a vertical loop is too that the geology varies significantly from region to region. So it's important that you have a good understanding of the geology that you're in order to determine what the best cost is.
And for a horizontal loop, Brian asks, how much land is he going to need for his horizontal loop to go in?
The average home is around 50 to 150, 50 by 150.
50 by 150 feet?
Yeah.
Yeah, exactly. Good, Brian says he answers it.
Excuse me, I have a question.
Yes, go ahead.
And to Nick, and my wife and I already have a geothermal installation in our house, and it primarily is for underfloor heating, radiant heating. And we would like to consider air conditioning with I assume the ductless fan coil unit is probably where we're at. But I have two questions. One, at what temperature do you typically run that? in terms of the water temperature, the fluid temperature? And then the second question is, how do you deal with the condensate?
Good questions. Those are questions that we get a lot with fan coil units. We run around 50 to 55 degrees supply water temperature on the cooling side. And then the condensation, we with a wall mounted fan coil unit, they have a condensate tray that's mounted directly into the unit. And then we have to run a line down to a drain for the condensation, or we have to pump up to a drain if we have to go up in elevation and we can't use gravity to our advantage, we'll pump it to a drain.
And so have you ever gone back to someone who has a geosystem like this gentleman and added fan coils for people who wanted air conditioning?
We have, and one of the nice things about a hydronic system is the versatility. And we build our systems with that versatility in mind. So if there's ever a time that you wanted to expand, or we've done systems in the past where, hey, we're just concerned about heating now, Nick, can we add cooling in the future? And we've had applications to where we've added cooling in certain rooms, different zones, and we did it at different periods of time. So the versatility of a hydronic system is really nice. I mean, there's so many different things that you can do with a hydronic system, and they're easily you can easily add on to them.
I totally agree with what you're saying. I hope you can hear me. But I did want to ask the one question. Typically, we've been running our radiant floor heat with the geothermal at about 100 to 110, if it's really, is that still sufficient enough for the fan coil unit? As far as the heat side, okay.
Yeah, it is sufficient. And the one thing you want to be careful of is if you look at a fan coil unit or any heat emitter, the amount of heat output drops as the temperature drops. So as long as you have the temperature of 100 degrees in your design calculations for that heat emitter to perform, you'll be spot on. We usually design all of our heat emitters around 105 degrees and that's at design conditions when it's, below, you're looking at 0 or below outside. So any other time you're going to be a little bit warmer, but that 100 to 105, the gradient from the earth temperature 50 to that 105 it's not a steep gradient, and it's easy for the heat pump to do that. And if you operate at those temperatures, you're going to see, what we're projecting for savings on a project like that, you're actually going to see more because they're running at such a low temperature.
Does that fully answer your question? Okay, great. So Brian says he's planning a modular home in 2 to 3 years, and wanting to know, would you work with the builder to plan the system, or would you retrofit the system afterwards? Great question.
Brian, that's a really, really good question. I'm glad you asked it too, because it's nice, and we're starting to see, 10, 15 years ago, we weren't getting involved in the beginning because it was always an afterthought. But now we're starting to get involved in the very beginning. And what we're able to do when you involve us, and these are all, this isn't anything we charge for, that, this is just information that we put out there because we do want to see mechanical systems installed properly. We do want to see distribution systems installed properly, because there should never be a time that you're in your home that you're uncomfortable. So getting us involved early, I would definitely recommend. And even if you're planning 2, 3, 5 years out, we have many projects now that the planning is a few years out, and we love to get involved early because we can make small, minute recommendations, because this is what we do every day. And those little recommendations can make a huge difference on cost savings for the installation of the system, cost savings from an operational standpoint, and then last and certainly not least, the comfort.
Yeah, Nick has horrified me by telling me how many times he walks into a $1 million brand new home with a terribly designed duct system. So just because you have a brand new house doesn't mean you have a good distribution system. So if you get involved as the home is being built or before, you can end up with something much, much better.
Definitely.
So a question.
Love to be involved with the builders.
Yeah. Question here about the condensation drain trays. Have you ever had issues with mold in the trays or in the lines? And how accessible are those for maintenance?
The trays are definitely accessible for maintenance, and it's something we do in our regular maintenance plan. It is a mechanical system, just like anything mechanical. It's definitely good to maintain, but mold issues could be from another issue is typically where that will stem from, because just the moisture being present, moisture has to be present in order for the mold to grow. So what you want to do is you could definitely access them, but that's not the underlying cause of the mold issue. There's something else that's causing that mold issue.
Okay, great. Erica had a question a little bit off the topic of this case study, but can you convert a home with a hydronic system to an air source heat pump system if you can't or don't want to do geothermal?
Oh, definitely. Yeah, very easily, because you could, really leave your hydronic system in place. I'm not sure exactly what the distribution is or the layout, but we've been into homes to where they have a hydronic system in place. They want the cooling benefit from the heat pump, but they also want the heating benefit from it. So they typically end up just abandoning that old system and switching over to the heat pump altogether. But it also can be used in a supplemental case from the heating side.
Great, thank you for that. More questions. I'll just say that I want to thank everybody again for coming. It is 12:45, and we did say it was a 45-minute webinar, but Jonathan and I and the other HeatSmart directors and Nick are happy to stay on longer and take more questions as long as anyone has questions to ask. But if you are signing off now, please look for my follow-up email. Please fill out our survey, and thank you so much for joining us and having lunch with us today here at HeatSmart. What a great webinar it's been.
Yeah, thank you.
So, but please keep bringing your questions, because we are here and we're happy to give you the time. That's what we're here for.
Yeah, for sure. Any more questions, send them our way. We like to answer questions for sure.
Yeah. Anyone? Bennett or Lindsay, do you want to just say hello real quick? So I know there's people here from your areas, from your necks of the woods.
Sure.
And I see Guillermo's raised his hand, so I'll call on you next, Guillermo. So Lindsay, you want to just introduce yourself?
Sure. Hi, everyone. I'm Lindsay Spear. I'm the campaign manager for HeatSmart CNY. We cover Cayuga, Cortland, Onondaga, Oswego, and Madison counties. We've been running for about 2 years and are entering into our 3rd year coming up. And NP Environmental is one of our installers. So we're really happy to partner with HeatSmart Tompkins on these videos, and we'll be doing 2 more next week with 2 more of our installers. ACES Energy, which does geothermal, and Simply Installs, which does air source heat pumps.
Thanks, Lindsay. I'm going to go to Guillermo. Go ahead with your question, Guillermo.
Okay, thanks. And then, yeah, sorry, Bennett, we can go next. Question to Nick about radiant floor and how you can put in a geothermal system to run through a radiant floor rather than radiators or anything like that.
Can you repeat the question? I missed that one part of it.
Yeah, sorry, my connection's not great. Running heat pump geo into a radiant floor.
Yeah, are you asking if it's okay, or what the difference is between the different distribution methods?
No, so how would you run it into a radiant floor, an existing radiant floor system that's running off of propane or something else at the moment? So how would you retrofit into a radiant floor system?
Oh, okay. Yeah, it would just be a direct replacement. I mean, basically, we could take your boiler out, put in a heat pump. We do utilize a buffer tank with our systems for the heat pump operation, connect it up to the existing radiant distribution. Of course, we do an evaluation on the radiant distribution to determine, what the output is per BTU per hour per square foot on that, and then just make the connection. So it's really a simple transition with radiant heat.
Great, thanks. There's
Okay,
a
thank you. And so what temperature do you run that at typically?
Like
I'm sorry.
we like to
Just,
run around 100, 105. We can run warmer depending upon how your radiant tubing is installed, but we do like to design everything around that 105-degree temperature range.
Guillermo, are you all
thank you.
set? Great. So we have
Yeah,
another
thank you.
question, which I'm really excited about because I forgot to ask it myself, which is about the hot water, the domestic hot water. So with most of these hydronic units, do you keep the domestic hot water semi-independent to allow for how that water to be kept hot when you're generally using the system for cooling? So basically, how does it work to do the hot water? And then there's also a question about incentives, which I'll ask.
Okay.
Thanks,
Good.
Erica.
That's a good question too with the domestic hot water. The option that we really like on our standard, looking at 3 to 6 ton hydronic units, which would be a good fit for your average 2,000 to 3,000 square foot home. We like the 2-tank desuperheater assembly with an air source heat pump hot water heater attached to it. So what you get is you get the advantage of the ground source heat pump and the desuperheater. And then you get the advantage of the air source heat pump with the heat pump sitting on top of the unit. The two combined together really make for great efficient operation. And air source heat pump hot water heaters, you get a lot of bang for your buck with those. The savings are tremendous. And then when you add that additional with the desuperheater of the ground source heat pump, I mean, it's just it makes for a really, really nice hot water system. Gives you great temperatures, great efficiencies. And also you're getting an additional $700 just for that heat pump hot water heater. So I think that those are really a compact unit. You're taking advantage of the constant temperature in your basement, which is, being underground. I know my basement is a constant 45, 50 degrees all year round. No additional heat input at all. So it's just a perfect application for that. But if you don't have that basement and your mechanical room is outside of that underground portion, the 2-tank option without the heat pump hot water heater is good as well.
Yeah, it's really amazing how versatile this equipment is, all the things that it can do. All right, there's a great bunch of questions and I'm trying to sort through here. Somebody's asking about the incentives. So for ground source heat pumps only, not air source heat pumps, there is this year a 26% federal tax credit. And you of course have to have tax liability in order to take advantage of that. If you don't have tax liability, you can't get a tax credit. In addition to that, there are brand new incentives from the utilities that just started in April, and we're still getting a handle on figuring out how those work. They're pretty similar to the incentives that existed through NYSERDA previously, but they are administered slightly differently, and they each depend on the equipment that you're getting installed. So when you get a proposal for specific equipment from the specific installer, that installer will have figured out for you what that incentive for that equipment will be, if that makes sense. Nick and Jonathan, you might want to say more about the NYSEG. And NYSEG and National Grid have made it easy for us in this area that they are offering the exact same incentives. So whether you're in NYSEG territory or National Grid territory, it's going to be the same.
Yeah, I mean, when you look at the incentives too, and you look at the program in general, it really shows you the direction of where the state's going, and then we can be influential to other states across the country in order to begin adopting this technology to see what the advantages are. So it seems to me that in our conversations that we've had with the utilities, everything seems very positive and the benefits are tremendous. I mean, if you even look above and beyond the amount of money that, that's being offered to the consumer, but the overall benefits down the road for society in general are just tremendous. And when you look at the applications of these technologies and what the gain is, really the only barrier is just, trying to find a way around that, that initial upfront cost. But if you look ahead just little ways into the future, not far into the future, you're seeing significant gains. And then over time, the savings are just tremendous. The performance is tremendous. I mean, there's just so many benefits to it.
One thing that's nice about the new incentives from the utilities is they're guaranteed for at least 5 years. But we can't say the same for that federal tax credit. It does go down next year to 22%. So if you're thinking, oh, I want to do it this year or next year, let's do it this year, because you're going to definitely get a better break. So, okay, here's a question from John about radiant floor. Nick, he says, Nick, presume the 100 to 105 degrees for a radiant floor is a staple up radiant. What temperature do you run a radiant slab at?
Radiant slab, I mean, you can run right down to 75 degrees. It's pretty amazing how well a radiant slab does, especially if it's insulated underneath and on the edges. I mean, you can run down, our office building is a complete slab on grade, and we run radiant, and during the shoulder months, we run it at 75 degrees, and we're super comfortable. You get down into, the cold winter months, we may be up to 95 degrees.
Yeah, one thing I noticed from some of our happy HeatSmart customers is that they're actually keeping their house cooler or warmer than they expected to be. They're just, they have such an efficient system, it costs so little to run, that they are allowing themselves a little extra comfort as a payback, and enjoying their homes a lot more. So that's really nice how flexible it is. Okay, Erica, did your question about the de-superheater get answered? Erica says, do you need backup water heater with a de-superheater if you're not cooling with your system, for example?
Yeah, can you clarify that a little more, please?
Sure, definitely. That's a very good question. So anytime that you're utilizing the de-superheater, it's not going to do 100% of your hot water. So you always have to supplement it with it. So the question is, do you supplement with just purely electric, or do you supplement with an air source heat pump hot water heater? It really depends on the application.
Okay, if there are more questions, tell me. I don't see any more, but I'm trying to scroll through the chat here. And don't be shy, folks. You can ask a question in person too. Yes, Bill Nowak from NYGeo points out that there has been a lot of lobbying in DC to try to get the 30% federal tax credit restored. And at the end of last year, we really thought they were gonna do that. There's a tiny little lobby for geothermal, but unfortunately the solar lobby, which is much bigger, lets us work together on those things. So they're working on it. It seems though that the folks in the federal government are a bit distracted by a few other tiny things going. John says,
I wonder if we want to mention the NYSERDA 0% grants. I know Nick in his seminar said that there was some very low cost financing, but there's actually going to be, it's not available yet. We hope within the next month or so to know exactly when it'll be available. But NYSERDA's made a commitment to help the industry get back on its feet after the COVID pause by providing 0% financing for this kind of work. And so that's a pretty big up.
Yeah, so the 0% financing is going to be available, we understand, hopefully sometime next month. Is that right, Scott?
Yeah, this is Scott Smith from NYSERDA. So we're getting ready to make an announcement about that. I'm hoping the announcement's going to go out by the end of this week or early next week. The last information I have, but nothing is official yet. Just let me be clear about that. So the last information I have is that it'll be available starting June 1st. Obviously, it will be available in areas where the work is unpaused, not in areas where it's still on pause. It's going to be, we're going to announce a dollar amount. It's probably going to be something in the neighborhood of $20 million. It'll be first come, first serve, and the loans will be 0 interest for the life of the loan, 5, 10, or 15 years for all the loans issued within the time period.
Yeah, this is so exciting. And so you heard it here first, folks. Free money coming soon. You can borrow it for 5 years, 10 years, or 15 years. And the southern tier, including Tompkins County, is one of the first regions to open. So if you're looking to get a heat pump installation, also energy efficiency, air sealing insulation, and also solar, all of those you can borrow this free money from Scott personally. He's lending you
Yeah,
$1
right.
million.
I said it earlier too, but just let me be clear. I'm not really allowed to get out in front of the official announcement on this, but I just, since we're available, we had you here. I wanted to make sure that I let you know what I expect. Nothing is official until we release something on it publicly, and I think that should happen within the next few business days.
That's so
Great. Thank you, Scott.
I would add that because it's going to be available down here, you shouldn't delay. Don't wait until it actually comes out, whether that's 2 weeks or a month, because it takes time to get an assessment of your home, to get the proposals, to think about them, and sometimes there's options that you need to decide on. So if you want to be ready to take advantage of that, you should go ahead and enroll today and learn more about what it is that you're trying to finance down the road.
Brian is asking, yes, it's supposed to be available for a full year or until the 20 million runs out. A lot of us are guessing the 20 million will run out very quickly, and then we'll be begging them to put more money in the pot. But the 20 million is the first installment, so it's first come, first serve. And those of us with history of first come, first served money from NYSERDA know that it almost always runs out before the time limit. So, because people get excited, which is good. That means our programs are valuable. That 20 million sounds like a lot, but it really isn't. The odds it'll be renewed, that's get involved with the Renewable Heat Now campaign that does a lot of pressure on to get more funds freed up for heat pumps, and we'll hopefully get it renewed. But we're all working on it. No promises, but there's a lot of people asking for money right now. A lot of industries hurting, so it's we're very, very fortunate to have this this offering and excited about it.
Yeah, definitely. It's a good offering. I think John had one more question there too.
Okay, John, where's that question? If you see the question, go ahead and answer. Oh, is this the superheater? How does the cost associated with a superheater / air source heat pump compare to a small water-to-water heat pump for domestic hot water?
Under the current incentive right now, it's less for the de-superheater air source option than it is for the water-to-water.
And I think the incentives are still getting ironed out and aren't actually completely cemented yet. So I think people are working on trying to make sure that the incentives are actually incentivizing the best, most efficient systems for all of us. So stay tuned on that. But again, we will have on our website this incentives for the specific equipment that our installers have quoted us. But what's right for your home will be very specific to you, and the incentive will be calculated for what is being proposed to you personally based on the formula that the utilities put out. So I think that's the last word because it's after 1. This has been a great webinar. Thank you all so much for joining, and stay tuned for more webinars coming up. I know that I think Central New York is organizing some, and some of the other HeatSmart programs. We have Jonathan's presenting on Tuesday night a webinar on air source heat pumps, so sign up for that. And the following week, if you're just interested in air source hot water heaters, I'm going to be talking about those. So thanks everybody, and come to our website if you want to see the webinars you missed, and sign up for the future ones, and enroll with HeatSmart.
Thank you.
Thanks Nick so much. Have a good afternoon, everybody.